Hi, I'm Dr. Stuart Midgley, CIO at Doug Technology.
Hi, I'm Professor Catherine Trott, and I lead the Epoch of Reionisation program at the International Centre for Radio Astronomy Research at Curtin University.
We're a high-performance computing as a service provider, and we provide the fastest and latest equipment to our customers so they can access their data in record times.
My research hunts for the very first stars in our universe, more than 13 billion years in our past. As astrophysicists, we measure a large amount of data from our telescopes. And as our telescopes get bigger and bigger and more complex, the amount of data we receive from them increases incredibly. We recently did some work here with Doug, where we took a very large amount of data and processed it incredibly efficiently in a way that we wouldn't have been able to do with most legacy HPC systems.
Here at Doug Technology, we've got many scientists on staff, and so we're super interested in the science that our researchers on the system actually achieve. But what we're really about is cloud high-performance computing. We provide the latest hardware to enable the science to be achieved. When we were looking around for a storage provider, one stood out, and that was Vast Data. Their combination of solid-state disk and NVMe drives from Intel allowed us to deliver a fast and flexible storage system that allows you to search for your data wherever it is on the storage system. It doesn't matter whether you're doing large bulk streaming I/O or small seeks. All data is treated equally.
I look for evidence of the first stars in the universe with the Murchison Wide Field Array, a low-frequency radio telescope based here in Western Australia. From that telescope, we sift through terabytes of data looking for a very weak signal from the early universe. We both need to process a large amount of data, but also look at it in fine detail to ensure we have the best data of the highest quality going into our science. As we move to the next generation of telescopes, the Square Kilometre Array, which will be the world's largest radio telescope, we'll be collecting exabytes of data per year.
Rather than building just a large high-performance computing system and expecting our customers to adapt to how we've designed it, we go out and ask our customers, how do you want it to perform? How do you want to access your data? What do you need out of the system?
When we undertook our pilot project with Doug Technology, I really didn't know what to expect. I thought that this was going to be an HPC storage solution and a way that we could more efficiently process our data. But really what we achieved was something much greater. Not only did we process the data efficiently, the software engineers here at Doug Technology were really able to improve the techniques that we were using to analyse those data and ultimately produce bigger science and better science.
We've gone with our legacy storage solution from having storage interruption every few days to a system where I have not seen a storage interruption. That means that our customers have reliable access to their data 24 hours a day, 7 days a week. We're looking at a storage platform that isn't just going to store petabytes or exabytes, but it's going to store tens and hundreds of exabytes of data over many decades. We need a storage system that will scale within the data center, but will also scale globally and deliver the data direct to the scientists so they can get their scientific outcomes. Together, Vast Data, Doug, we will build that system and we will deliver fantastic outcomes for the world.